Or the Auburn one, he moved and took over the Vestavia program, so his thing died, and he just kept the Vestavias going. Trying to think of what other ones, but most of the time the people just quit. Oh, we used to go to Grissom High School in Huntsville, but then they started scheduling it during spring break. And then if it was either spring break, and everybody's like, I'm not going spring break, Mr. Ray, and I'm not making you because I don't want to go. I want to go to the beach too. And then she started scheduling it for like late April. I was like, dude, in late April, we're done. Like, it's like, check please, you know? Anyway. But anyway, yeah, there just used to be a lot more out there. All right. Let's see. So flip to probability. Let's see if we can knock out most, if not all, of this counting principle stuff. Okay, so we have gotten through permutations. We did do the definition of combination, right? So it has that extra factorial on the bottom. If you want to look at these two right here, remember permutation takes the first number on top, then subtracts them on the bottom. Combination does the same thing, first number on top, subtracts them, but also puts the number on the right on the bottom as well. So combinations, because you're dividing by an extra number, oftentimes are much smaller. Sometimes they're the same. Like if I have 5C, 5C4 versus 5P, hold on. No, like 5C1 versus 5P1. 5C1 is 5 factorial over 4 factorial, 1 factorial. 5P1 is 5 factorial over 4 factorial. And you can see the only difference is this one divides by a 1 factorial. Well, that's not doing anything. So sometimes they'll have the same value, but most of the time your permutations are bigger numbers because we're counting the order. And if there's more ways that can happen to change order and it actually matters, then there would be more outcomes. And we'll talk in probability a little bit more specifically why, when, and where we're going to use those permutations and combinations. So anyway, we were going through this list, I believe. It's been a couple days, but we were going through this list on what a combination, what a permutation is, and how you can identify it. Did we get through all these?
Yes.
Okay, so I think we ended up the batting order in baseball. We're talking about that would be definitely a permutation. And because the order in which you do that would have an effect possibly on the outcome. I mean, there's no guarantee. I mean, the other day, some dude for the Orioles threw a no-hitter. And it probably wouldn't have mattered what order. I mean, if he's striking everybody out and grounding everybody out, everybody's getting out. It doesn't really matter the order. So it doesn't mean that it would have an effect on it, but it's possible that it would. And there's a lot of strategy in baseball in that way. So we would definitely go with permutation. Okay, so circular and flippable are the concepts I want to talk about today. So if you ever have a situation and you're trying to count the number of ways something could happen, and the scenario is not linear. Now, when I say linear, I'm being very vague. Like, if you're going to think about this room, for instance, and I'm putting you in different seats in this room, there's a lot of different ways I could arrange you, right? Assuming the order had an effect on the outcome. There's lots of seats. We probably have 24 seats in here. There are, 18 of you guys in this class. So that would be in a situation like if I was counting the different orders, well, there's 21 seats, there's 18 people. So 21P18 would be how many ways I could arrange that. And you could think about that differently as well. However, if I ever have a situation, this is really easy to do, really easy to mess up, okay? If I have a circular situation, now again, circular I'm using loosely. It doesn't really matter that your table is actually a circle, okay? The idea is that it is kind of going in some kind of a loop. You could have a hexagonal table with 6 people on it. You could have an oval table with a bunch of people on it. But if I ever have a situation where everybody's kind of arranged in a way that it's not linear or not whatever, but like everybody say they're kind of all looking towards each other in the middle, regardless of exactly what shape the table is, We call that a circular situation because, for instance, even if I take A, C, B, these three people, if I just rotate their seat, the perspective they have doesn't change. If all that you know about this situation is the people on the table. Now, when I sit down at a table with my wife is an artist. She's very visual. She wants to sit in the chair that has the best view. I might appreciate that a little, but I don't appreciate it that much. Okay, so I'm going to go, where do you want to sit? And she'll go, oh. She either wants to sit in the sun or where it faces something beautiful. I could care less. I can sit and stare at a wall. Okay, I'm just hanging out with people. All right. Point is, if those things matter, then obviously changing seats matters. But if we're talking about a situation where everybody's just arranged at a table, and what's important about that is that they're maybe just in community with each other, then if everybody gets up, moves one seat over and sits back down, has anything really changed? No. But like if we were in this room and everybody, like if everybody here moved up a seat and it kind of zigzagged, right? Because the person in the front now no longer has a seat, so he goes to the back of the next one. Everybody moves right here. You kind of follow me? It would definitely change the perspective of the room, right? I mean, pretty soon you in the back are going to be up here in the front. Pretty soon you're going to be maybe in the back. That's changing, but in a circular situation, as people are moving around, just picking up a seat and moving, the perspective doesn't change. So when you're counting that, you would not want to count that movement. Well, that becomes really difficult to visualize how to do this situation when you get more than just three people. I'm going to walk you through three. But it's really easy to calculate. So if you ever find yourself in a situation that is circular and say there's 10 people, we're not going to, if I say how many different ways can you arrange 10 people, instead of saying 10p10, right, or 10 factorial, you're going to say 10 minus 1 factorial. It's always one less. Okay, now I'll prove that to you with this. So this is 3 keys arranged, all right, as many different ways as possible. Now I'm going to label them A, B, C, and I first want to talk about linear. If I had A, B, C arranged linearly, and I said, how many ways can you arrange A, B, C? The 3 letters where order has an effect on the outcome. You'd say, well, I could have A, B, C, I could have A, C, B. I could have B, A, C, I could have B, C, A. I could have C, B, A, and I could have C, A, B. Those are the 6 ways, or the 3 factorial ways to arrange 3 letters, right? But that's linear. If I arrange these on a circle, I want to show you that this ends up being not 3 factorial, but actually 3 minus 1, which is 2 factorial when it's circular. Now you may look at this and go, I see 6 right here, Mr. Hurry, but let's take a closer look. Right here, these are my options. A, B, C, A, C, B, B, C, A, B, A, C, C, B, A, C, A, B. But if you think about it from the perspective of the person, here person A has what? C on the left, B on the right. Okay? Person A, C on the left, B on the right. So this one's really like number 1, isn't it? Person A, C on the left, B on the right. This is also like, not person 1, scenario 1. So those, even though I had rotated them right here, I basically said, I'm going to rotate that, and now I have ACB, that's this. Or I could rotate it down, now I have ACB, that's that. So those 3 are all really like each other, aren't they? There's really no difference that happened because of the circular nature. So that's one option. Now, here's one where you have person A, you have B on the left and C on the right. Here's A. B on the left, C on the right. Here's A. B on the left, C on the right. These are just like option 2. Those 2 are just like this one.
Is it always going to be like from the perspective of like you as that person kind of?
If I talk about how many ways can you arrange something around something circular, and there's no other things going on like, oh yeah, but one side of the room's really pretty, the other side's really ugly. Oh, one side's right near the back door or whatever. There's nothing else going on that would make the perspective change other than that little circle of people or a circle of whatever. This could be like charms on a round bracelet. This could be things hanging off of a necklace. I mean, these kind of things, if you're counting the ways that can happen, if it's a circular situation, just taking something on my necklace and rotating it around, technically I didn't really do anything to the way I put these on my necklace, right? It looks different, but it's just because I'm just moving things around this circle, kind of like I'm moving things around this circle. So if you find that it's circular and there's nothing else going on, instead of saying how many things, 3 factorial, you're going to say how many things, decrease it by 1, then factorial. And you can see, look, these are really the only 2 situations there. Now, at one point, I tried to do a better job of this. I tried to do one that had 4 on there instead of 3. But 4 factorial is 24, and I had 24 different diagrams to put on this page, and it just became like kind of tedious since I'm kind of making these by hand. So I just stuck with this to kind of prove my point that when you have a circular situation, you basically don't count like you would normally do in what I might call a linear situation. Y'all with me? But the key is just decrease it by 1. Now, and then take the factorial. Now, sometimes that circle is interrupted, okay? And this bothers some people, but you need to just trust the math. Sometimes there might be a clause in there, like for instance, okay, I want to arrange 3 people in this room, but wait a second, I want you to leave this seat open, okay? So nobody gets to sit in that seat, but you can arrange the 3 people in those other seats. Well, if I were to say, hey, keep that seat open, then that's different. Because now person A has an empty seat to their right, and they have person B to their, an empty seat to their left and person B to their right. And if I rotated them around and you still kept this open, empty seat left, B to the right, this is now different, isn't it? Because now you have empty seat right, C to the left. So sometimes when you have some kind of situation, I call it the clasp, because like on a necklace, there's a clasp back there, right? Are you with me? And if I have a clasp there, something that interrupts the nature of it, and it's usually like a seat that's empty, or maybe there's a post in the way that changes that perfect linear perspective. If that's the case, then we're not going to go -1 factorial. Now, if you look at it, if that seat has to remain open and you're just moving A, B, and C in the remaining seats, now it kind of is like having this linear situation if I stretched it out. And when you have a clasp on a necklace, not that everybody in here is wearing necklaces, but if I had one, let's just say I had 3 things that were on my necklace, okay? And I wanted to go, you know what, I want to change this up a little bit. I got a bead over here on the right. I'm just going to swing it over on the other side. Well, if I didn't have a clasp, I could just move that bead around and it would look different, wouldn't it? But I really didn't change the order that they were put on there. They're still sitting there. That would be kind of like me going, hey, I'm just going to rotate everybody around. It doesn't really change anything. But what if there's a clasp? If I go to rotate that bead around, it hits that clasp and drags the clasp around to the front. Do you really want the clasp in the front? Right, and if you don't have a necklace or whatever, I mean, I don't have any necklaces, so I'm not wearing those. But if I'm just saying, you don't want the clasp sitting there in the front, unless that becomes some dumb, trendy thing, I suppose. But so if that's the case, if you have something like a clasp, then the flipping, the changing, just the rotating without changing order, but just rotation, that circle part, it eliminates the circle part, okay? So when you're looking at these, if you see anything about round and they mention clasp, treat it like it's linear. Or anything like an open seat, or maybe I told you, hey, Biff has to sit right here. So Biff is sitting here, but the remaining 3 people are going to sit in these other seats. Biff never moves. Biff's acting like the clasp. And there's only one way to put Biff there, but there's 3 factorial ways to arrange the remaining 3 people. So you got to look for things like circular. If it's circular, you just subtract 1 factorial. But if it's circular with a clasp, you treat it like it's linear. And we'll do enough of these, you'll be okay. And then the last thing is this, is flippable. Flippable, if I had 3 people at a table and I went, hey, what if I were to take this and pick the whole table up with the people and flip it over on top of each other? Well, you don't do that with tables, but I could do that with a necklace. For instance, what if I had a red, white, and a blue charm hanging from my necklace, right? And I didn't want it to go red, white, blue. I wanted it to go blue, white, red. Well, all I would have to do is to pick it up, turn it around, put it back on, right? I didn't really change the order, but yet it looks like I changed the order, doesn't it? Well, if you think back to these, we basically just said in a circular situation, all of those were just duplicates of these, right? Well, what if this is a necklace and it's not person ABC, it's charm ABC dangling from a bracelet or a necklace, right? Look what happens if I take this right here, pick it up and flip it. I'm going to keep A where it is. A stays where it is, and B goes there, and C goes there. Isn't this and this technically the same thing then? Visualize that. If I picked this up, this is a bracelet that's on my wrist that has ACB dangling from it, and I pick it up and flip it. Doesn't that B go here, and that C go here, and now these look the same?
But then couldn't that account for any of the other options depending on which axis you flip it?
Yes, but what that does is that eliminates half of them. So what you do, I think if I'm hearing you right, what that means is if it's flippable, even if it's not circular, even if it has a clasp on it, right? If it's flippable, which is only going to be like key rings, necklaces, bracelets, things like that, that literally you could take off and flip. You can't flip a round table of people. I mean, you could, but it's painful, right? So if it's flippable, it eliminates half of the other options. So basically you divide by 2. All right? So if you ever see a flippable situation, divide by 2. If you ever see a circular situation, you subtract 1, then do factorial. And if it's both, you subtract 1 factorial and you divide by 2. So looking at some of these situations, like right here, how many seating arrangements can be made for 10 people sitting at a circular table with 10 chairs? So if I have a circular table with 10 chairs and I'm arranging 10 people, well, that didn't even suggest that there's kind of a seat that has to be left open or one of the guys has to sit here. There's no other conditions, right? So totally circular. I'm going to come in here and say, all right, 10 minus 1 factorial, which is 9 factorial. You don't have to write 10 minus 1. It's 9 factorial. Now, how many ways can 8 charms be arranged on a necklace that has a clasp? Now, if it has a clasp, is it really considered circular? No. So I'm not going to decrease the 8 by 1. That's definitely going to stay 8 factorial. But because it's a necklace, like a keychain, like a bracelet, it's flippable in nature, isn't it? So I am going to divide by 2. Now, if there is anybody out there thinking, well, hold on, Mr. Hurry, I've got a necklace, and it's got this big, whatever, Constantino cross or something on it that's exquisitely made, but there's one side that's pretty and then the other side's not pretty. So if I flip it, it's really not flippable. Did it describe that? So we're going to generalize. But yes, if you knew more information, then of course, yeah, you might have to factor that in. But in the absence of that information, you're going to go, all right, based on this, we're going to be very, very general. We're going to say, flip it away. And that's true on a key ring too. Like a key ring is just a ring, right? And you got a bunch of keys on it. What if I had a blue key, a red key, and a yellow key? But I'm like, oh, I don't want the blue key there. I want it on the other side. Well, I could rotate it over. I didn't really change the order, did I? It looks different, but I didn't undo them and change any order right there. Flipping that blue key over didn't really change the way I put them on there, but because it was circular, I'm going to say, well, 3 keys, 3 minus 1 factorial or 2 factorial. But because it's key, I can flip it, can't I? So I'm also going to divide by 2. But if there was like a key fob on the key ring, right? Like I have this key fob that keeps me, that's the name of these if you didn't know that, but whatever. It's a fob, which is the stupidest name ever, but whatever. If I had one like this, I can't pull this over, can I? So if I'm like, oh man, I wish this key was on the other side, or I wish this little tile was in the middle, I can't do that because the key fob's in the way, can I? So that key fob took away the circular nature of this, didn't it? So instead of having 3 things on there or whatever and being instead of being circular with 3 and saying 2 factorial, I'm going to go, you know what? This broke up. This is almost like a clasp. it broke up the circularity of this and made it just 3 factorial. But is it flippable still? Yes, because it's flippable. I can flip this around and say, oh, look, now the tile's on the left. Oh, look, now the tile's on the right. The flippable part of it, I am going to divide by 2. Y'all with me? Okay, if you have any issues when you're doing your work, as long as you're checking your work, you're going to catch those issues. But I've thrown a few of those out and on some of this, so we'll just plug through here and see what happens. So first one, how many unique ways can John, Biff, Rhonda, Julio, and Fred be seated around a table? Now again, we don't know much about this table, so it says around a table. No, it didn't. It said be seated at the table. But this says around the table, so we're going to go with round. So that perspective as they're sitting around this thing, I'm going to assume that what about this? It's circular, so instead of going 1, 2, 3, 4, 5 factorial, I'm going to say 5 minus 1 factorial or 4 factorial. Now this says Johnny has to sit near the seat nearest the door. Okay, all of a sudden my perspective is different. Maybe Johnny's got to slip out early. He doesn't want to make a scene, who knows what. But things have now suddenly changed about this. The perspective now is different. It's not just focused in on the circularity part. So in this case, if I'm like, all right, so there's evidently this door in the room, right, in the back, right, and Johnny has to sit right there, and he's stuck, which means all I really have is 1, 2, 3, 4 people that I'm going to be arranging, aren't I? Right? So those 4 people are sitting in these 4 seats, but because he's kind of acting like a clasp, he is blocking that circularity. And if I take this and stretch it out, it's really like a linear problem now. So in this case, I would go 4 factorial, which is really bothersome to a lot of people because they're like, wait a minute. If I just arranged all 5 people, that would around the circular table, that would be 4 factorial. And that blows people's mind a little bit. But again, just trust the math. Or this, Barbie has a clasp less, so no clasp. A clasp, I probably shouldn't have a blank there. A claspless bracelet, and she wants to attach her 5 different charms to the bracelet. Now there's no clasp, all right? How many unique ways can those charms be arranged? Well, what are you going to say? 5 minus 1 factorial, which gives me 4 factorial, divided by 2 because it's flippable. So it went from 24 ways down to 12. Actually, it went from 120 ways down to 24 ways, and then down to 12 ways once you divide it by 2. So not as many options as you would think if I just had 4 people lined up in a row. All right, how about 30? There are 10 students in a class that meets in a room that has 12 chairs. How many ways is it possible for the students to be seated? Now, there's a couple ways to think about this. There's one really hard way, and then there's one really easy way. So I'm going to first do the hard way because I actually used to teach this, and then I'll show you the easy way. So what's got to go on here? Let's visualize this class. Heck, we'll make it this class. There are 18 students in a class that has 24 chairs. How many possible ways is it for them to be seated? Now think about it. As you're walking in the room, let's just say we have no seating arrangement, right? As you're walking in the room, there's obviously different ways you could sit down, right? But what 2 things are going on? Or what if I am making a seating arrangement? What 2 things must I consider as I'm placing you? Remember, there's only 18 of you.
Or the empty chairs.
Okay, so where the empty chairs should be. So technically, that's the same thing as saying, which chairs am I going to choose for my kids to be in, right? I have a question for you. Let's just say I want these 18 chairs right here. Does it really matter if I go, all right, I want this. Oh, wait a minute. No, I want this. Did it really make a difference? So when I'm picking the chairs, you could argue that it doesn't have an effect on the outcome, right? So you could say, all right, first let me pick the chairs. There's 24 chairs, and I have to pick 18 of them, and the order doesn't make a difference. Doesn't have an effect on the outcome as I'm picking chairs. C. Now, at that point, what have I picked? The chairs. But I haven't done what? arrange the actual people in those chairs. Okay, how many ways now can I arrange my 18 students in those 18 chairs that I picked? 18 factorial, which is the same thing as 18p18, is it not? Okay. And I could write 18 factorial. And do I multiply or add these two things? Why multiply? Because I got to do this, I got to pick the chairs, and then I got to arrange the people. So, and now I want to show you the math on this. Look what happens when you actually write out the math. What does 24C18 mean? 24 factorial over what? 6 factorial, I'm subtracting, and 18 factorial. And then what does 18p18 mean? 18 factorial over what? 0 factorial? Right? Okay. What cancels on this? The 18s, and what's 0 factorial? 1. So I'm really just left with this, aren't I? Anybody know what 24 factorial over 6 factorial is? Isn't that do that? Isn't that 24 factorial over the difference factorial? Isn't it? So isn't this 20 factorial? If I were to simplify this, wouldn't I write 24 factorial on the top and then subtract these two and get 6 factorial? Right? Well, if this is equal to this, is equal to this, is equal to this, then isn't this the same thing as this? If they're all equal? Well, doesn't that kind of still make sense then? I really don't have to do it in 2 choices. I could say, you know what? It's really, there are 24 chairs to choose from. I am going to choose 18. And while I'm choosing the 18, I'm going to count the different orders that I'm choosing them, because that's as if I'm placing people in different orders. That's the same thing as this. So you could do a problem like this. I used to put it on the test thinking I was really clever. And people would always, I'd make people think this way. Then I had a couple kids go, why don't you just do this, Mr. Ray? I'm like, yeah, you're right. It is the same thing. So I'm not quite as clever anymore. But 2 ways to do the same problem. So this one on yours won't, obviously, the key won't be 18 and 24. It'll be with 10 and 12. But how could I do this? I could really just say, hey, there's 12 chairs to choose from. I'm going to pick 10. But as I'm picking them, I'm going to say the order does matter, because different orders of those 10 is like placing the kids in different order. And I can knock this thing out with just a simple 12p10. Or I could suffer a little bit and say 12c10 times 10p10. That would mean the same thing as that 12p10. Moving on. Great little math team question right here. 31. If I draw 8 points on a circle, in fact, this would be an easy one. I'm going to give you a harder version, but you'll see it a couple times. 8 points on a circle. So here's my circle. I'll just simulate it with 8 points, just randomly. So those are 8 points. It says I'm going to start drawing triangles through any 3 of these points, right? And I know it's got to be a triangle, because if all the points are on a curve, every 3 points I pick, even stuff like these 3, are going to make a triangle if I connect them, aren't they? Right? So how many different triangles could I pick? Could I create here? How many different triangles? Well, what are you picking to make a triangle?
3 points.
3 points. What are you picking them from? From those 8 points. That sounds like an 8p3 or an 8c3. What do you think it is?
8p3, because the word kind of matters, because you don't want to select the same one.
Let's just, how about this? Let's name them. Decide. We're picking, we know it's 8 something 3, right? We're just trying to decide on that letter. If I pick A CE. Is triangle ACE different than EAC? Is it different than CEA? Are any of those triangles different? So did the order that you picked those 3 points have an effect on the outcome? No? What's got to be a what then? See? Combination. You follow me? Now, what if I said 8 points on a semicircle like this? What if I gave you a semicircle and I'm going to put 4 points down here and tell you what, how about 9 points? 5 points on the curve. Now, make triangles. Wait a minute. Now, can I pick any 3 points? Why not? Because what?
Because they're gonna be like different angles and stuff. Like that first like
There?
it's gonna be like that first that's gonna be different than
That's like linear.
Yeah.
It would be linear, right? When you make a triangle.
Yeah.
So if I pick any one of those three, any 3 of those 4, I'm not getting a triangle out of it. So what I end up having to do is making sure what?
So, like you subtracted it then.
Okay, I could potentially do that. We can visit that. But what I would, if I'm counting the ways that I can actually do it, I got to make sure that either all 3 come from the curve. That would be fine, wouldn't it? What about 2 from the curve and 1 from here? That would still be a triangle. What about 1 from the curve and 2 from here?
Yep.
That would be a triangle, but all 3 from here, no good. So let's talk about that. How many ways could I pick all 3 from here? What's the math on that?
There's 4 ways.
There's 1, 2, 3, 4, 5
There's
points.
So
I'm choosing 3. So what?
5C3.
5C3. So that's how many ways if all 3 are from the curve. All right, what if 2 are from the curve and 1 is from here? Well, how many ways can I pick 2 from that? 5C2. But how many ways can I pick 1 from that? 4C1, which is also 4. Because the order doesn't matter, right? And aren't I picking that, those 2, and this one? Now, what's the other option? I could not pick 2 from here. I could pick 1 from those 5. What would that be?
5C1.
5C1. And then 2 from these 4. What would that be? 4C2. But I got to do this and that, don't I? So this is going all 3 from the curve, 2 from the curve and 1 from the base, 1 from the curve and 2 from the base. But isn't this saying I could do it this way, or that way, or that way? And what does or do? Now, you mentioned all I really have to do is make sure I don't do what?
bottom ones.
That I don't get all 3 from there, right? So this math, it's the same thing as doing, Mr. Hurry, it doesn't really matter where you pick the 3 from. You can pick it from any of those 9. As long as what?
Minus.
You don't pick 3 from there. And I could go minus 4C3. Now, in this case, that's true. But sometimes it's harder than that. Like if I said quadrilateral, then there's more than one way I could get messed up, right? If I pick 3 from here and 1 from there, that doesn't make a quadrilateral, does it? 3 from here and 1 from here makes a triangle. 4 from here is linear. So I would end up having to subtract more stuff. At some point, subtracting more stuff might be just as hard as just finding what does work. And these look vastly different, don't they? But if you do the math on these, 5 factorial over 2 factorial, 3 factorial gives me 10. You do the math on this, 5 factorial over 3 factorial, 2 factorial gives me 10 times, and this, just trust me, gives me 4 right here. 5C1 gives me a 5, 4C2, 4 factorial over 2 factorial, 2 factorial gives me 6, 5 times 6, and I end up getting 10 plus 40 plus 30 is 80. If I've done my math right. If I haven't, I'm gonna have to go back and find my error. But this right here gives me 9 factorial over 6 factorial, 3 factorial, minus 4 factorial over 1 factorial, 3 factorial. This gives me 987 over 3, 2, minus 4. This gives me 12 times 7, which is 84, and 84 minus 4, also 80. So you can see the math works both ways. We're not going to do any simplifying. So we're just going to leave it like I initially had it, or like you have it here. But you do have to be able to think and start putting these combinations, putting these permutations together. Are y'all with me? Yes, no? How about this from a list of 10 books? How many groups of 4 books can be selected? Anybody?
The combination, because it doesn't matter the order of the books, it's groups of books. Yeah.
10C4? Yeah, because it's like, think about it. If you walk into a bookstore and you need to buy a calculus book and a history book and AP Psych book or whatever, you have to buy 4 books. Does it really matter the books you get, the order in which you got them? No, you're just throwing them in the buggy, right? Throwing them in the cart or whatever, putting them in your. So the way it talks about selected. Now, if I said how many ways can 4 books be arranged or whatever, I thought there was some other wording in there that suggested order might make a difference, then use a P. But in this case, I don't need to do that. So to me, it's pretty clear that it would be a combination. How many baseball teams of 9 members can be formed from 14 players?
Oh, no.
What do you think?
14P9.
I'm going to go with combination there because I'm just picking a team. If I'm just picking a team, like if I say, hey guys, I need 9 of you to come to our state tournament and test. I want, and I start picking 9 people. Does it really matter the order in which I picked those 9 people to be on my team? Now, what would change that? If I was talking about a batting order or a lineup or something like that, then that would make a difference. Or if somehow the way I picked you put you in a certain position, somehow, maybe, then that might make a difference. But I don't see that, so I'd have to go with a combination and go 14C9. What about how many ways can a club of 13 members choose 4 different officers?
E.
Feels like a P on that one, right? Because if I have 13 members, if I need to pick 4 officers, me just picking you 4 people, right? If I just pick you 4 to be my officers, well, you might be the president, might be the vice president, might be the treasurer, might be the secretary, might be parliamentarian, whatever. There's a lot of ways to do that, right? Just within those 4. So suggesting just picking the 4 doesn't matter. According to this, it sounds to me like different officers, unique, really feels like a P there, 13P4. 35, how many ways can a club choose a 4-person committee? Sounds like a C there, combination, because just being on a committee, if you're on the committee, you're on the committee, right? Suppose there are 9, we've already done that. Oh, we'll do it again. Suppose there are 9 points on a circle. How many different 4-sided quadrilaterals can I do?
Combination.
So 9C4. Suppose there are 8 points in a plane. Now, if I just stopped right there and said 8 points in a plane and said how many distinct triangles could be formed, what could potentially get me in trouble if I just said 8 points in a plane? Yeah, if I ever had points that were linear, then I would make a triangle, right? But they said no 3 of which are collinear. So if I can't draw any line between any 3, then it's basically like putting them on a circle, right? I'm just picking random 3 points. I can make triangles 8C3. Anyway, plug through those, or if the bell's about to ring, see what you can do. We're going to finish up all this so I'll answer any questions that you have issues on Monday. Are y'all going to be here on Monday? Forgetting. No. Yeah, because AP Chem, What did we talk about? No, we're all gonna be here tomorrow, right?
The soccer game to be out.
Oh, yeah, who's going to be in class tomorrow? Who's going to be here? Raise them high. Oh, yeah. Okay, we'll talk about this on Monday. We've got the time to burn. But guys, make sure you at least get all of these counting principle problems done and put stars by the ones you have issues with. So we're gonna talk about those quickly on Monday, and then we're gonna move into probability. All right? Y'all go get some rest, man. We got some sleepyheads in here today. We're fighting.
Like 4 hours.
I know I only got 5.5 last night.
I do like a bunch of team sports.
Had a friend's birthday party. Just kept talking. I'm
Yeah.
like, dude, it's midnight. I go to work. Struggling this morning.
I'm gonna go make that math test up today after school.
Go. Good luck.
Thank you.
Is it being shown like live? Is there, like,
It's on that like NFB.
Yeah, there's NFHS, which is like a sports thing.
you gotta pay
I
like
guess-
$10 or something to watch?
Yeah, or if you have like a membership. I mean, I'll put it on the news somehow because we work for the Chelsea game.
Yeah.
Yep, I'm excited.
Good times. Good luck.
Thank you.
All right, man. Be good.